Next presentation from the same company, NetTV Plus, is performance gains with Ansible in CDN environment. Will be presented by Sibin Arsenijevic. Sibin, the floor is yours.
Well, hello everyone. Okay. We'll just wait for the presentation. Oh, great, thank you. So, as I was announced already, my name is Sibin Arsenijevic. I'm System Administrator in NetTV Plus. This is what I do. I won't spend too much word on it. And what do we do? As Matti already said, we are covering the IPTV OTT service. So we're doing the ex-Yugoslavian channels for ex-Yugoslav diaspora all over the world. We're doing 3 continents presently, and we will be probably doing the 4th very soon. So we're constantly optimizing, constantly doing everything we can that our customers get the best possible solution that there is. So we identified a few problems with everything that, with every large-scale deployment such as this one, that is the constantly provisioning large number of machines. So we wanted to have a system that would provision, 100 machines in one batch to make everything work as it should. And also we wanted we identified that one of the problems was that administrators were basically wasting their time doing each of the machine either via scripts or manually, which is the worst possible option. So, and those processes were all error prone. Well, we got administrators which would sometimes omit just a tiny bit of configuration somewhere, and then we would spend a lot of time working through every possible solution problem until we find some simple, stupid error somewhere. So time to run updates also was a major concern because, as we all know, Heartbleed was a big thing, and also some other exploits that were found recently. So we wanted something that would push all the security updates as soon as possible. So we wanted to have something that will update all the servers in the shortest possible time and have every other machine in our system patched and secured. So those are just the basic problems that we identified in our setup. So we chose Ansible because it's agentless, it's Python based. I personally like Python, but it's basically, if you're not writing plugins, even with plugins, it's basically language agnostic. So you can write a plugin in any language, just return certain values, and we'll get to that later. So we have the open source solution, which we like. So we have the parallelism, which is a great thing because we can patch the whole system of hundreds of servers in a matter of seconds, in a matter of minutes, if not seconds. So it's easy to learn. It has a fairly easy syntax, and it's easily upgradable and expandable with modules written in basically any language. So also the big thing was Python API for running playbooks from scripts. So we were able to make something like Ansible offers an enterprise solution, which is Ansible Tower, which we didn't want to use. But we opted to just write our own API calls so that we can run all the playbooks by ourselves. So from any other provisioning system or our own CDN, let's say, database. So security questions were addressed by patching a large number of machines, which takes time, of course, if done manually, or you could do some sort of scripting, but in Ansible it was really all about this. So the idea was that you just call Ansible on all hosts, call the module app, and then update cache and update the bash to the latest state. And that was it. That was about 2 minutes for hundreds of servers. So that was the first big gain that this system brought to the table. So also we are able to now have certain types of Playbooks, which enable us to give our NOC members a chance to run some playbooks that we have predefined for them, so that they can do some kind of optimization if needed on the fly. So that was also a very big thing. And also the other part of like programmers and others could also use these playbooks to build their own testing environments, and we will ensure that every single one of them is exactly the same as we want it to be, so that we could test everything and know that everything is ready for deployment. Okay, I know you can't read this. It's not very visible, but generally playbooks are really easy. They are done in YAML, and they're pretty much the I don't know, the easiest thing that any configuration language has. In, I don't know, for example, Puppet, you have to learn a sort of Ruby, but here it's just easily readable even by NOC members which are not skilled at programming. So that was it. You can also run playbooks defined on many criterias. So I will show you that later. So we made the system for updating our applications by using by practically just dropping a binary file to predefined folder and then configuring a structure that is basically variable. And when we do the actual update, it just updates everything as it should. So we don't like waking up early because we have 3 continents to cover. Our basic time for update is 7 a.m. or 6 a.m. in the morning, so we don't like waking up too early, so we just pre-copy everything, of course using the same script, the same Ansible playbook, and then just update at the given time. So that's the variable. You'll see it on the slides. You can just copy it directly. You can make SVN or Git checkouts, whatever you like. That's it. So, as I said earlier, you can define every playbook can be run or not run based on any type of criteria. So, you can, for example, update the application only if the application previously hasn't been updated. So, you can check if maybe the file you pre-copied earlier has maybe been, I don't know, hacked by someone. You can check if the file is different. You can update it only if needed, only if everything matches your configuration system, which is completely outside the target machines. So that's it. This is a kind of a playbook, and I think this is the worst if statement ever written, but it does the job. It does the job perfectly, and of course you can make a Python module just for this. It's really easy. But I wanted to show that even without Python modules, even without some programming knowledge, you can write something like this. But this works, and it covers every possible scenario of file being damaged, of file being not copied or copied, but the application is updated, every single aspect of that. So, another thing that we wanted to do is have a system which is easily integrated with our existing system. So we wanted to have something that we won't have to integrate with our existing CDN, let's say, database. So we don't have to have too much development effort, and we wanted to have things as consistent as possible. So we went with the solution to make our own, which is also very easy. You'll see in the next slide, I guess. So we made a connection, which is, I don't know, 60 lines of Python. So it fetches all the hosts, and it gives us the groups of hosts as you should see in the next slide. So yeah, so when you execute the script, you get just this. You return JSON, and that's all it has to do. It just has to return JSON. It returns the host groups and hosts inside those groups, and also the host vars, which are the variables specific for those hosts. So that's all it has to do. There are some specific types like meta tag, which enables us to limit the number of calls to the API, which is of course expensive in terms of round trip time and load on servers, but everything else is just pure Python and pure JSON. That's it. So, for example, when Matthias said already that we monitor everything, we wanted something to have the possibility to use those measurements results in our playbooks. So I wrote some simple, it's really simple, it's like 60 lines maybe. Plugin to run Munin run, so it basically invokes Munin on hosts and gets the results and pushes them back to Ansible's variables. So you get the possibility to, let's say, restart a service. Is this Munin graph is showing that the logs are stuck or something. You can do that automatically. Of course, you should fix the application first, but if you have to do it, you can do it. You have the means to do anything with it. So it can react, it can do any kind of thing with any kind of the Munin variables which you can get from Munin. So the benefits we got from this was that provisioning time for one machine, which was around 5 to 10 minutes, went down from 30 to 40 minutes by using, depending on the package installed. So basically the only thing limiting now is the speed that the packages are installed. That's it. The rest of the playbook run in 1 or 2 minutes. That's it. So we provision one machine, but if we get a batch of 10 or 20 machines, we have to do them. We get to do them in the same 30 minutes. So we can run it parallel. So we can provision 10 machines in 30 or 40 minutes. Of course, depending on the bandwidth available to download the packages, but with 10 gigs, that's not really an issue. So time to update application shortened from 2 hours when it was done without the scripts manually, to 30 to 45 minutes with scripts, to 1 to 2 minutes using Ansible. So we are able to push this service to our clients really, really fast, so they experience minimal downtime. So we can get the whole system updated in about 1 or 2 minutes. Of course, the only real requirement for Ansible is that you have SSH and you have Python. That's it. So some switches, for example, like Juniper switches, they have Python on them, or you can get Python on them. So you can benefit from all the Jinja 2 templating language. So you can, for example, template a complete switch layout, switch configuration, and push it to the switch. Or you can, for example, include in Ansible Playbook that if this machine is provisioned, put its configuration into the switch config and commit the changes. It's all possible. So you can automate even the networking part. We're not doing that at the moment, but maybe one day we will. But only if any of the systems gets these requirements, you can do it. So yeah, possibility of making an error driven to an absolute minimum. Well, that's a bit of overstatement. Its ability of making an error or making a complete dead system, it could be driven to minimum, it could be driven to maximum. If you don't test anything and you push it, you might break the whole system. If you're doing something like, I don't know, SSH change, for example, if you don't test it, if you're doing it wrong, you will break everything. So it's a double-sided sword, so to say. So some caution to be considered here. So that's it. Another big thing was enforcing parameters. So we were constantly getting into even though we have procedures for those, into situations where some admin was doing like, oh, I'll just change this parameter here just for our colleague to have an access there and something like that. And we would also, and he will naturally forget. In about a month or two, we'll still find some accesses which probably wasn't meant to be there anymore. So By doing this, we can just run the same playbooks multiple times and get the absolute same results and enforce some parameters. So we can enforce that, I don't know, a list of public keys is the same on every server, which has to have some kind of same user base. So that is also a benefit from all of this. So yeah, looking at the graph, that's about it. The green ones are Ansible, and they're pretty small compared to any other mean we did before. So yeah, sometimes it can fall short. So at previous versions of Ansible, we got this a few times. So machines that hang a specific point could compromise the whole build-out, so the whole rollout. So machines get in sort of a limbo, and they do not time out. The Ansible itself will time out, but sometimes it doesn't know what to do. But in the recent versions, we haven't had any kind of these errors. So the one thing that is different for Puppet, for example, is the procedural nature of the playbooks. So if you have a large number of hosts, and some of them are in the States and some of them are here, the whole playbook is waiting for that one server in US to respond back. So that is probably one of the major issues. While you should compartmentalize to make some groups of hosts which are in a way smaller, so you can just run playbooks in order to have the results on all other, and then leave the slowest ones for the end in the separate run or whatever. Yeah, as always, any configuration management system is hard to maintain without a good system management database, because if you're changing a large number of files by hand, you'll get it wrong somewhere. And version control is also, if you're not using it, you should. If used wrong, overriding of the variables could lead to some unwanted results. But if you're not using too much of the groups, it will be okay. So yeah, and Jinja 2 templates, which are used for configurations, sometimes can be hard to read. So we'll see in a minute. So this is a Jinja 2 template for a startup of a Java process that we used. So this whole thing, it's quite a mouthful to read, and also to decipher what it really does. So if somebody wants to do it, please do. I'm not going to go into that. So that's about it. We have some other stuff here, but you won't be able to see them. This is something I got inspired by yesterday. I wanted to do Just Ping. If you ever used a site like Just Ping, which returns the results from all the web servers from around the world, it doesn't work. So I thought of it. Okay, let's do this in 5 minutes, and I made something like this. So it's I practically use all my servers to send a ping to my wanted host and return me their GeoIP and their response times to all of those addresses in JSON format. So I can also use that to make a backend or something else. It's really an open possibility. If you have an idea, you probably can make it. You can also look at Ansible in a way that it could provide a great parallelism for your own apps, for your own plugins, if you want to make them. So that's it. That's it.
Any questions?
Well, okay. Hi, I'm Rastko from Faculty of Organizational Sciences. I was wondering, did you do some comparison between other provisioning systems? And did you consider Salt as an alternative to Ansible?
I did, but I finally opted to Ansible. I guess I was documentation for Ansible was pretty bad when we started doing it. So it promised some great things like Ansible API, which was something that I really liked because we didn't want to make to use Ansible's dashboard, for example. We don't want that. We wanted to make our own stuff. So that was one of the biggest points. Of course, agentless design was winning up for Puppet because Puppet needed an agent. So that's it.
What about Salt's ZeroMQ usage? Did it affect any of your designs, or would it increase some bandwidth or just network communication between the server and hosts?
And I really didn't go that far into one with them.
Okay, thanks.
Okay.
I don't see any more people on the mic, so thanks a lot. Thank you.